Hello and welcome back to Shenzen IO. Now that the levels are getting a little more complicated, I'm going to change the format of these videos. I'm going to showcase a solution or two that I came up with, and then I will look online and find a solution that's hopefully better than mine, and I will show you that one so that we can maybe learn as we go a little bit and apply it to future levels. So let's jump right into virtual reality buzzer and see what we can come up with. Okay, so in this level, this is a radio RX. The RX emits a signal, either a -999, a 1, or a 0, and it controls the buzzer. So when it emits a 0, the buzzer should be off. When it's 1, the buzzer should be on. Verification down here shows that when it's 1, the buzzer should pulse on and off, and when it hits 0, it should turn it off, and -999 just basically means no change in the buzzer. So my first thought is use this big guy here, and we'll use the DAT register to keep track of when the buzzer is on and off, and the ACC to control the pulsing of the buzzer. So let's start with that in mind. Let's drag in RX here into X0. Let's test if it's equal to X0 is equal to -999. If it's not, we know we need to toggle the buzzer. So in that case, if it's not -999, we will move X1 to the DAT. So basically, if it's coming in as 1, it'll move 1 to the DAT, and if it's 0, it'll move 0 to the DAT. And this should be X0. And then we'll test the DAT. Test is equal to 1. If it's equal to 1, we should turn the buzzer on. So let's put a plus down here. And we'll do, if it is equal to 1, we're going to not, which means we're going to turn the ACC. If it's 0, it'll go to 100, and if it's 100, it'll go to 0. So that'll create our pulsing effect. And then we'll test the DAT to see if it's 0. If it's 0, we will make sure it's plus. We'll move ACC to 0. We'll move 0 to ACC. That'll basically turn the buzzer off. And then we just need to move ACC out P1. So that'll go to the buzzer. So this will basically change this to 0 to 100 if it's a 1. If it's a 0, it'll turn it off. So that should give us what we want, and we just need to sleep 1. And let's test it out. So it doesn't look like it's working. We have just a flat line down here on the bottom. So I guess let's step through it and see what's going on. Alright, so here we have a 1 coming in RX here. It's going to test it and see that it's not -999, so it should move X0 to the DAT register. But right now, so it looks like it only flashes 1 as soon as we use the value on the X bus, it goes to the next number. So that's why. So it's actually moving -999 to the DAT, I believe. Let's see. Yeah, so it's actually moving that. So that's not going to work. We'd have to rearrange this whole statement, which isn't going to work. So let's try something else. Let's try something like this. Let's try again. Let's keep this same principle in mind with trying to use, if it's not -999, the buzzer has changed, and we'll just know it needs to be 0 or 1. So let's test. Let's test the incoming X0 and see if it's -999. And then if it's not -999, we'll not. So that'll change the ACC to 100 or 0. So basically, if it's 1 or 0, it'll not the ACC, which will basically turn the same thing. It'll turn this to 100. It'll turn it to 0 if it's already 100. So basically turn it on and off, because as you can see, this basically comes on, off. So we can just keep the not alternating symbol should work. And then we'll just move ACC down. Let's move it down X1. And so we'll grab it down here. We'll come down here, and we'll hook into X0 here. And up here, I guess we'll just sleep for 1 till the next frame is ready. And down here, we'll do the same thing. We'll test equal X0 if X0 is equal to 100. That's basically testing to see if X0 is on. If it is, we will start the pulsing of the buzzer, which this is going to be the buzzer ACC. So we're going to put a plus symbol here and we'll put not, which will basically alternate the ACC every other frame. And then if it's not equal to 100, that means it's off. We will put a negative in here and we will move 0 to the ACC. And then we'll move ACC out P1. We'll attach P1 into the buzzer here, and then we will sleep for 1. So because this is coming on an X bus, this will wait till this executes, because it won't do anything until it receives a signal on this line. So let's step through it and see if it works the way I think it's going to. So right now it's evaluating -999, which is what it is. So it's going to skip the not, and it's going to move ACC to X1, which is a 0. So it's going to receive it down here. It's going to test it right away to see if it's 100. It's not, so it's going to move 0 to ACC. So there you go, it moved 0 to ACC. It's going to move ACC to the buzzer, and it's going to sleep for 1. Let's advance it a couple frames here. Let's see, so now it's got to the 1 here, so let's step through this one. So it's testing it to see if it's -999. It is not 999, it's 1, so it's moving the ACC to 100 here. And it's going to move 100 down to this line here. There it goes there. It recognizes that X0 is 100, and it's going to not the ACC, which is going to turn the buzzer back on basically. So there's the buzzer on, and now it's not going to change this value because it's not going to see that it's not going to not it because there's not a 1 or a 0 here, so it's going to leave this 100 and move it back down to here. So that's how we'll keep the buzzer on. So it looks like that is working. Let's go ahead and simulate it. So it appears to be working. I feel like we could do it with 1 microcontroller instead of 2. Good on lines of code here, but we didn't do good on power usage or production costs. Let's try another solution. We're going to go back to the big unit here. Drag this big unit in. Let's move him onto X bus. He has to come into an X because it's an X bus output right here, so we have to keep it at X. And let's just grab P1 and take it over to the buzzer. And let's try something different here. Let's move X1 to the DAT, so that way it's gonna, the minute it receives a X command, it's gonna move it to the DAT register, which will basically tell me whether the alarm is on or off, I believe, and this should be X0. Test to see if it's equal to 1. So we're going to test the DAT if it's equal to 1. If it is 1, we're going to try a new command, and we're going to put positive here, and we're going to put jump to on. And if it's negative, it's not 1, we're going to jump to off. On down here, and we'll do off down here. Right, so when it's on, we want to basically do the same thing we did before. We're going to use not to make the ACC pulse from 0 to 100. We are going to move ACC out P1, let's send it off to the buzzer. But then we need to sleep for 1 because we sent out the signal. And then we're going to move, since we sleep for 1, we got to move X1 back to the DAT because we're going to have a new X1 value, or new X0 value, sorry. So after we sleep, we're going to get a new X value because it's going to come down this verification tab and it's going to move to the next number. And we have to check to make sure that that is not a 0, because if it's a 0, it's going to turn the buzzer off, otherwise we're going to leave it go. So let's test the DAT here to see if it's 0. If it's 0, put a positive, let's jump to off. And if it's not 0, that means the buzzer's still on, so let's just put a negative in here and let's jump back to on. So this basically creates a loop. Once it gets into the on cycle, it'll knot the ACC, it'll move it down to the buzzer, it'll sleep for 1, then it'll check the DAT again. If it's not a 0, the buzzer's still on, so it'll jump back to on, and it'll just keep doing this loop until it finds an off command. Once it gets the off command, it'll jump to the off command here, which we will do move 0 to ACC, move ACC out P1, and sleep for 1. We have just enough lines for this. It gets stuck in the on loop until it finds the DAT equals 0. And when it does, it'll jump to the off command, which will basically execute the 0 to ACC. It'll move that to the buzzer, and then it'll sleep for 1, then it's going to come back up to here, advance it, and see how it goes. So it's basically skipping the whole programming because it's sensing that it's not 1. So here it found a 1, so it jumped to the on command. Let's reset this and step through it. Alright, so it basically 1 is on the X0 right now. It's testing it to see if it's 1 right here, because we moved X1 to the DAT here, so it is 1. So it's going to jump to the on, which is going to knot the ACC, which makes it 100, which turns the buzzer on. It moves ACC to the buzzer, and it's going to sleep for 1. Now it's checking the DAT again to make sure that it's not 0, because if it's 0, we need to turn it off. It's checking his DAT now, and it's jumping back to on because it was not 0. So it's basically stuck in this on loop until we get a 0 coming through. Alright, so here comes the 0. It's going to test it to see if it's 0. It's going to jump to the off command, which is going to move it down to here. Move 0, sleep 1. And it looks like we're working. Let's go ahead and simulate this and make sure it works. This is better power, but I used a lot more lines of code. Last one I only used 9, this one I used 14. But I could probably iterate through this again and see if I could get rid of some code. But let's move to a solution I found on the internet and see how that compares and see what we can learn from it. Okay, this is a solution I found by Quigley Stardust. I'll put a link to his video in the description, but this is how he solved it. This is a pretty good solution, I feel like. I might have gotten to this if I iterated over my design one more time, but he basically did target x, or test if it's greater than x0 is greater than 0. So basically if it's a negative 999 or a 0, it's off, and basically he just testing to see if it's on. So if it's greater than 0, it's definitely on. So if this is not true, it's not greater than 0, it just sleeps for 1 and jumps back to the start. So it basically creates a little loop going here until it recognizes that the system is on. Once it's on, it moves 100 to P1, sleeps for 1, moves 0 to P1, sleeps for 1, so that basically creates the pulsing cycle. And then he tests at the end of that cycle to see if X0 is 0, which means the buzzer would be off. And then he jumps back to on if it is not 0. And it basically gets stuck in this loop until it's 0 to see if it's equal to 0. If it is equal to 0, it'll skip this phase and come back up to the front top here. If it's not equal to 0, it'll jump back to the on and it'll stay in the on loop here. So let's go ahead and advance through this a little bit, make sure it works. Looks like it's working. The power lines of code is 9, that's pretty good. His power is going to be a lot less than mine. Let's go ahead and simulate it. What we're missing here is we need to recognize that we could do, instead of testing for 999, I should test for it's greater than 0. So his solution is actually relatively good here. We got low on the production cost, low on power usage, and lines of code. Solution is definitely better. So what we learned from that is basically these loops are very nice and handy. It's a nice way to jump in and out of like cycles. So when we have a cycle going here, we could use the jump loop command to basically stay in this loop until we find the condition to get us out of it and jump out of it. And then we should definitely pay more attention to, I was testing for negative 999, which means I had to set a condition for 1 and set a condition for 0. Where basically this one was just looking to see if it's on. If it was on, it sent us in this loop, and if it was off, it just stayed at 0. So much simpler. So that is the virtual reality buzzer. Thanks for watching this episode. We'll see you next time.